I'm going to show you a bunch of examples on how we simplify negative exponents. So we're going to see that the negative exponent and its base always move to the bottom of a fraction, and the exponent becomes positive. So for this one, this becomes 1 over 5 to the positive 3. And x to the minus 4 becomes 1 over x to the positive 4. This one is a little different because the y is the base of the negative 2 exponent. The 3 is not being raised to the negative 2. Based on the order of operations, we do exponents and then multiplication. So the 3 is just being multiplied. So we actually have 3 times y to the negative 2. So this y to the negative 2 becomes 1 over y to the positive 2. So now we have 3 times 1 over y to the positive 2. And then we just multiply. We basically have two fractions. This 3 is the same as 3 over 1. And when we multiply across, we have 3 times 1, which is 3, and 1 times y squared, which is y squared. So we can see by looking at the original that the 3 stays on the top and the y squared, or y to the negative 2, becomes y squared on the bottom. 7 to the minus 1 becomes 1 over 7 to the positive 1, which is simply 1 over 7. Now we have a negative exponent that's already on the bottom of a fraction. So we'll see that since it's already on the bottom, it's actually going to move to the top in this case. And we know that because if we replace this 3 to the minus 1 with, that would be 1 over 3 to the positive 1, right? Then we can treat this as dividing by a fraction. So we then multiply by the reciprocal. So this is 2 times 3 over 1. And the 2, we can look at that as being over 1. So now we end up with 6. So had we simply moved the 3 to the top, we would have ended up with the same answer. We would have 2 times 3 to the 1 power, which is just 3, and that's 6. For this one, we can see that this whole thing, everything inside the parentheses, is the base for the negative 3. So everything is going to move to the bottom. So on the top, we're just left with 1. And on the bottom, we now have 2x to the third, and I still need the parentheses since the 2 and the x are both part of the base. And then we have times 3 y to the negative 2, so the y to the negative 2 can actually go to the top. So now on the top we have 1 times y to the positive 2. And then we can simplify this further. The top just becomes y squared. And on the bottom, we can apply this 3 to both parts of the base. So we then have 2 to the third times x to the third times 3. 2 to the third is 8, and then 8 times 3 is 24. So on the bottom, we have 24x to the third, and on the top, the y squared. For this one, the x to the minus 9 is 1 over x to the positive 9. So we have 1 over x to the positive 9 times x to the 4th on the bottom. And when we have two exponents with the same base and they're being multiplied, we can add. So that becomes 1 over x to the 13th. Another way of doing that same problem is we know that when we have exponents with the same base and there's division involved, we can actually subtract. So if we're going to leave it on the top, we would say that this would be x and then negative 9 minus 4. So the new exponent would be negative 9 minus 4, which simplifies to x to the minus 13. And since we have a negative exponent, we would then change that to 1 over x to the positive 13. So we can see that this works both ways.